Our third speech will be given by Professor David Booth. And David Booth leads the UTS Fish Ecology Lab in Sydney. His lab researches mainly in the marine fish ecology on the coral reefs in Uterus and along the temperate coast. And they are particularly interested in the sustainability of iconic species such as sea dragons and in the effects of climate change on fish and their habitats. So let's welcome David. Hello, David.
Hello, can you hear me or see me?
Okay, fine.
Is that okay?
Okay.
Can I share my screen?
Okay.
I do have a recording there, but I'd rather share my screen. So if it all goes wrong, please play the recording.
Okay, you want me to play the video or you want to?
No, I want to do the live one, if I may.
Okay.
So I'm going to assume you guys can all see that. Thanks very much for the introduction. So I run a fish ecology lab here at University of Technology in Sydney. And so I'm just adjusting something here, that's better. And so we study a range of things, but one of the things we're really interested in is the ecology and population biology of cygnathids. So you'll hear some talks from us tomorrow regarding sea dragons, but we've also got collaborative links with David Harasti, who's talking in the conference on the seahorse work, and pipefish as well. And so I just wanted to talk a little bit today about pipefish ecology. I've really enjoyed all the talks so far. There's been a really great emphasis on phylogeny, developmental biology, physiology, maybe to a lesser extent ecology. And I just wanted to point out that all the evolution and natural selection operates at the level of ecology, operates at the level of demography, at growth, survivorship. And these are important things we have to keep looking at. And so this, I guess, rather basic talk will be on some of the demographic parameters in these little pipefishes found around Sydney. So in my state of New South Wales, in Eastern Australia, which includes Sydney, there's around about 19 species of pipefish recorded. The latest one you can see down the bottom is a very beautiful one named after David Harasti, who might be online here. We're very proud of that one. They're all protected under our Fisheries Act for collecting, but of course, that doesn't stop habitat destruction threatening them. So the two animals I want to talk about today are really quite common in a sense, although we've been recording fewer and fewer of them through time, which is a bit of a concern. And they live in urban estuaries and other estuaries, but certainly around Sydney. They're both in the genus Stigmatoptera. One's Argus and one's Nigra. Quite similar, but have slightly different demographic characteristics, and they occupy the same seagrass beds. So where are these seagrass beds? The work we did was in around Sydney, in a place called Botany Bay. And anyone who's flown into Sydney, you'll recognise this as the place where you land, and the first place a lot of people enter Australia and fly over. So that obviously suggests it's a very industrialised area. So the bay is quite a beautiful bay, and on the southern part, the green bit you see here is a large marine reserve area. We've noticed a decline in the seagrass there, and also in the areas that we've been studying, shown in yellow here. So you can probably see the extensions of the runway into Sydney, a city of 5 million people. And just to the right of that is an area called the Foreshore Drive area, where there used to be huge Zostra seagrass beds, and they've been eroded away steadily, and more recently by a large port development to the east or the right-hand side there. So this was one site. The other site you can see in yellow down here is at the downstream end of what's called Georges River, which empties into Botany Bay. Again, a very popular place, all sorts of issues with pollution, seagrass die-offs, etc. But there are pipefish, and there were. So the two species are quite similar. They both live in high abundances in some seagrasses, some slight preference for different seagrass for the two species, but they were both found in the extensive Zostra beds that we saw here. They prefer pretty good conditioned seagrass, long, dense beds with little epiphyte or overgrowth. They have various preferences I won't go into. Sometimes you find more males than females in the seagrass bed, so it appears like there might be a skewed sex ratio. And both of them seem to prefer epibenthic copepods and amphipods, based a little bit on the structure of their snout, as work in the past has done. So they're fairly similar. So we're interested in basic demography, as I mentioned, particularly growth and survivorship. And we wanted to see, first of all, how you would measure this. Now, there are a couple of different methods, and we use tagging. Elastomer tagging has been mentioned by other people. And this involves, and we can do this, and in fact, we tried this on these animals. That is injecting animals we caught with a seine net with fluorescent elastomer paint. Now, this seemed to work all right, but we injected hundreds and they seemed to be fine, but we only were able to recover a few. So it didn't seem to us this was a very good way of estimating growth, at least. So another thing that fishery scientists often use is they use otoliths, which, as many of you probably know, are ear stones of fish. And as I will tell you, this is no easy task in a pipefish, but it's possible. These otoliths, as I'll show you, put down rings that we were hoping were daily. So to prove this, we had to validate them. Once we did this, and I'll talk a bit about that, we're able to use them to construct growth curves for the animals. And we could then ask the question, what is the longevity? And did their growth differ between the species, between the sexes? And what about seasonally? So here we go. So first of all, the otoliths. Well, it turned out the otoliths was so small and so fine that simple light microscopy and polishing didn't reveal the rings. We had to turn to environmental SEM, scanning electron microscopy, to get the images. But as you can see below, we've got some beautiful images with these growth rings quite well resolved. Otoliths are mainly calcium, and this is deposited, we hope, daily, because then one can see these rings and count the rings to get some idea of the age of the animal. There's 3 different pairs of these otoliths, but the lapilli, the middle-sized ones, appeared to work the best for us. So here are a few images of the otoliths as polished, and of the 2 species. They indicated a birthmark, we decided, and the successive rings we were hoping were daily. So the standard method for testing this is to add a fluorescent dye to the water of the animal in an aquarium. The dye takes up in the fish, but also in the outer edge of the otolith. Then you remove the dye, leave the animal for a week or so, do it again, and leave the animal for a bit longer, and hope that you're able to see 2 fluorescent rings on the otolith. Between them, the number of rings equal to the number of days. And to cut a long story short, we did find that for both of them. And this is just an indication on the right of an example otolith, and on the left, some of the fluorescent alizarin shown there. So yes, so very simply, we could use these otoliths as indicators of age and even growth. Also, we're able to get some estimate of the longevity, and I guess slightly to our surprise, just about every animal, and we had a wide range of sizes, we believe we covered most of the population in our collection, were under 150 days old. So these animals spent their whole life cycle in about five months or less, making them one of the lowest living or shortest living species of vertebrate, which is interesting. And of course, I'll talk about sea dragons later. They're up around 6 to 8 years, so quite different longevity. Most of the animals are around about 150 millimeters long, depending on the species. So step number 1 is a standard growth curve. And here is the von Bertalanffy curve of the growth data. So we see that obviously older ones are longer, and there's quite a deal of variation, first of all. The dark circles represent agates, and the open circles, the other species, Niagara. You can see a difference, and you can also see a lot of variation within the species in terms of length at age, but they certainly level off. There was an odd individual out to the right there. We did find it was older, but there was some problem resolving its otolith. So we believe just about all the animals are gone after about 150 days, which is quite short. What that means is, and then we decided to say, well, okay, what is the difference between the species, but also more interestingly, what is the difference between sexes and among the species and among the seasons? So I'm going to dissect this graph a little bit more in successive slides, but pretty much the dark growth curve represents animals collected in winter, The dotty curve represents those collected in summer, and there's also autumn and spring. So you can see, obviously, there's differences. So for instance, this species here, the females and the males, if you look at the growth curves there, you can see overall females grew bigger and a bit faster than males. In the females, you'll notice the winter growth is significantly slower than the summer growth, and the same with the males. And in fact, that growth is quite different. So for instance, at about 100 days old, a winter female would be about 100 mils and a summer would be about 140. So a 30 to 40% length difference, which translates to about a 210% body weight difference. So individuals in summer at a given age, about 100 days, would be twice the weight of an individual in winter. And the males had a similar difference. So you can imagine fecundity probably usually has some relationship to body weight. So animals in the summer months would probably be able to have twice the fecundity of animals in winter. Similar story for the other species, although in the males we weren't able to collect many or enough to perform growth curves in some seasons. So what does this mean? Well, apart from the interesting demographic fact, it means that because the animals are so short-lived, you get this interesting phenomenon of animals that are only living through a winter and other animals only living through a summer. So there's summer and winter fish. Most fish species that I know of live at least a year or more, and so are able to experience all the seasons and all the different selective pressures. So I guess in summary, the animals have a very short lifespan, less than 5 months. There are major, I would say, seasonal growth differences, generating the two facts generating the idea that there are summer and winter individuals, potentially with different selective pressures, and certainly potentially higher fecundity of the summer animals by quite a considerable degree. So just to finish off on a nice negative note, this is the seagrass bed as it exists today. It's been carved up quite dramatically by port development. And these figures just show how the seagrass has dropped off over the last years and been replaced. The Zostera Posidonia has dropped off. There has been an increase in a seagrass called Holophila, which is not of great interest to these animals anyway. So port development, as you can see there, and other factors have led to the destruction of this once very productive bed. So it's quite concerning that these animals live in these areas and are subject to this sort of pressure. So I think I'll leave it at that. And if anyone has any questions, I'm happy to answer them.
So I think we have some time. So anyone has some questions?
So I would actually have a question, if this is okay.
Very good.
Thank you very much for this talk. That's great that you can actually go with the othelids and look at how old these animals are. So from the data that you've shown, it looks as if the males are living longer. Is this correct?
Not really, maybe slightly. There wasn't much of a difference between females and males. I should have pointed out a little more.
Okay, so just on one figure.
Yeah, just, I don't know if you probably can't still see that yet. It's probably very, very slight difference in terms of longevity, for sure. Yep. Okay, because in terms of life history evolution, I mean, what one would expect if it's a sexual reversal is actually that the males would rather be the ones that are longer living because of sexual reversal, as usually it's the other way around. But you do not see. Yeah, they might live slightly longer, but they were smaller. So it's interesting. Yeah, I'm not aware, and it would be an interesting extent to the study to look at fecundity in males, for instance. So is there, you know, obviously when the males are larger, that sometimes means there's male-male competition or whatever. And I don't know a lot about that for sure, but it would be interesting to look more at the behavior of reproduction, I guess you'd call it. Mm-hmm.
Thank you.
Thanks.
David, can I just ask probably a stupid question? Do you think by having by having two different like seasons within the same species, you could be potentially looking at process like sympatric speciation or something like that? Have you tried to?
It's possible, although I'd be pretty sure that there's overlapping generations here. So, you know, a winter animal, for instance, would give birth to offspring that then live through spring, which would give birth to offspring that live through summer and that kind of thing. So, you know, there probably aren't any sort of long-term different growth morphs perhaps, but you know, there might be such a lot of plasticity in the animal it's able to survive in the different seasons. But yeah, it's possible, I suppose. Have to do some genetics.
Really cool. Thank you.
Thank you.
Okay, and more questions? If you don't have other questions, maybe we'll take a short break. What do you think, Olivia?
Yes, I think it's good to take a short break, and maybe we can just stay online and chat a bit.
Yeah. Okay.
Because otherwise there is not much
Everybody.
interaction.
Okay.
Enjoying the conference. Thanks for doing all this.
Thank you, David.
Take care.
Actually, David, are you still around? Because there was another question now popping up from Kenyon.
Yes, I'm just back. So I just turned it off so I could have a scratch. But anyway.
Ground truth, the off-lit reading.
Say that again, sorry.
In the chat, maybe Kenyon, are you online, Kenyon? Then you can just ask in person. Where is he? You need to unmute him. Where is Kenyon?
Maybe you can ask the question again. Sorry.
Yeah, I asked the question again. So is there a way to ground truth the off-lit readings?
Well, I suppose when you say ground truth, I mean, the main thing people wonder, we see these lovely rings, and of course, it's very tempting just to assume they're yearly or daily or whatever. So the ground truthing to me was the validation. Now, admittedly, it was done in the lab where most of this is done, but we were able to be pretty solidly validate that each ring represents a day of growth and is deposited daily. So once you do this for each individual animal, you can work out its age, and of course you have its length, and hence the generation with enough animals over a range of lengths, you have the generation of these growth curves. So, you know, to me, that is as validated as you can get.
Thank you. So Yali, can you maybe unmute Kenyon? I think you only have the rights to do that. I can't.
Yeah, okay.
And you can speak in person.
Yeah, in the meantime, I did this for Nerophis lumbriciformis and Signatus abaster, and I tried to more or less calculate their ages, and we could measure the daily rings. They then have like an I don't know if this word exists in English, like an amorph zone, where we had to try to use tetracycline to measure and calculate the rest of the rings. And that's how we came up with 3 years, more or less, lifespan of this pipefish. So yours...
Yeah, the only difficult zone to resolve was the center, and that from various bits of evidence, like the fact that the very tiniest pipefishes, the center was still there, but there was almost no rings beyond that. And the fact that the center is a very small area and width compared to the rest of the otolith suggested to us that this was, otoliths usually have an amorphous period in the middle when they're, before they're hatched in general in fish. So this is a pretty strong and reasonable assumption. I think that this is a birth region. So that's why we're pretty confident that the rings we see are the rings from birth to capture.
I've got another question, if possible. So you say when you were trying to work out if the otolith rings were daily, have you been able to breed these fish? Are they breedable? Because they're only if they're only living for 150 days, then you might be able to just have them from when they're born and then determine it that way. But I don't know if they're breedable or not.
Yeah, they probably are. Obviously, we brought them into the lab and they do quite well as far as just general maintenance and that sort of thing. They're pretty hardy and that sort of thing. But no, that wasn't part of our ambit. But again, you know, that'd be an interesting thing to do. But I think there's little to no question with the validation that these are daily rings, and therefore,
yeah, sure.
It's pretty firm.
Cool. Also, one other thing, do you have a thought on why there's a male skew in the places where you sampled these? And do you think that has any?
A lot of this species, or one species occurs in New Zealand and Australia on the southern part, and one in southern Australia. A lot of the general biological work was done in Western Australia, which is, you know, a world away from our side of the coast. It's 3,000 kilometres away pretty much. And that's where some of the information on the male skew. I think I mentioned in one of these slides, we didn't even get enough males in some of the seasons to construct growth curves. So my feeling is that we haven't seen a skew in particular in these particular beds. So it might be a geographical difference.
Okay. Thanks.
Right.
So there was another question by Cheng Quinn. I asked him to unmute now. I hope this works now.
Sure. Thanks for all these questions. It's excellent.
Okay, maybe I read it. So to David, these two pipefishes give brooding once a year. Can you find the otolith rings with varied according to the season changing?
That's a good question. I mean, we obviously have collections of otoliths of fish collected at different times of year. The validation we did was once only. I can't even remember what time of year it was. And so, yeah, it's possible there's some sort of variation, but I don't think so. The other thing you can measure with otoliths, which we could go back and do, is look at otolith increments, because that's another way of estimating growth of an individual and patterns of growth. You can use the width of that between those rings as a proxy, which we have not done for this animal, but could do.
Thank you. I hope this answered the question. Yes, okay, thanks.
Thank you.
Yeah, can we change the settings such that everyone can unmute his or herself? Because I think that's a bit annoying to, sorry.
Okay, Olivia, I will change the settings.
Because I think this would facilitate discussion quite a bit.
Yeah. Okay. So now that everyone can communicate with each other, please.
All at once?
Everyone.
Interesting.
Okay, so now you can speak together.
Yeah, they have so many questions.
So David, would you be able to do some otolith measurements for our pipefish if I provided you with some of them?
What sort of beer do you have there? I kind of like beer from your part of the world in general. So maybe just include that with your samples, and we can see what we can do. If you send images, or you can do this yourself, if you can get the images of the otolith, there's cheap and free software to be able to do these measurements. But yeah, the polishing I know was quite a trial.
Microchemistry or so, but maybe we can have a chat later about this if you.
Yeah, certainly we do microchemistry in the lab with other species like eels and tropical fish coming down and that sort of thing. And there's a window, because these particular species would probably be quite good for otolith microchemistry, getting elemental signatures, because they're estuarine, and estuaries are good places. They change in salinity and temperature and that sort of thing, which is picked up on this microchemistry. So yeah, there's plenty of potential for that, although they're tiny otoliths, so you wouldn't be able to resolve chemistry across the otolith as much as, say, bigger fish.
Okay, so I might send you an email later on if this is okay.
Please do. Yeah, I'd love to hear from you.
Great, thanks.
I have a small question, David.
Very good.
You use the stone in the air to identify the catfish, right?
Sorry, not getting the question.
Yeah, so I can speak again. You use the ear stone.
Ear stones, yeah.
Yeah, to identify the pipefish, right?
That's right, yeah.
So, the stone is very small. How you can find it? I'm very curious about it.
Oh, I remember the lead author of the paper, Karen Parkinson, did her master's with me. And we do lots of otolith fish earstone processing in the lab. And I think we were both in tears trying to find these for a while. They're absolutely tiny. And of course, the skull is really ossified. But it's amazing with a bit of practice how you can become good at it. And within a week, she was certainly an expert. We found them, then we polished them and realized they're so tiny, maybe 30 microns or 40 microns, very, very tiny, smaller than a hair's diameter for sure. Preparing them, once you have them prepared, they can be analyzed. But then, as I said, the light microscope didn't have the resolution even under oil microscopy. So we turned to SEM, which saved the project, I guess. But a lot more effort.
Yeah, thank you for your answer. Maybe you could have a break now.
Oh, thank you. Thanks for all those questions.
One question.
Fantastic.
Thank you.